Right, so I'm kicking us off, so here we go. Good afternoon, everybody, and thanks for joining for what is the first in what will be sort of an ongoing series of Q Evaluator and performance office hours sessions. So the agenda for today is looking at how we can, first of all, sharing a bit of details of how we're looking to improve communication on the Q project. From the evaluator perspective, a high-level recap of sort of where are we, things. A brief interlude at that point then as how the old, i.e. current, and the new evaluators differ. Then a status update on the evaluator and performance work, followed by Q&A. But as I said, please just interrupt if at any point it's sort of easier for you at that point in time to sort of jump in with a question. So one of the things that we've spoken a bit about recently is how we can improve communication via the Q open source project. Firstly, a thank you to those who have provided feedback on the performance side of things in the Slack channel. That feedback has been, first of all, incredibly constructive and well received on our side of things. So thank you to those who have engaged. Thank you for your patience. And to echo what we said in the discussion that I've linked there, 2857, apologies, we have dropped the ball on the communication when it comes to performance and work on the evaluator. So this is really part of a concerted effort to improve things, and we would appreciate your feedback on whether we are hitting the mark with that new communication and whether you're getting critically the information that you need. And as we'll see, as the changes start to land, that the performance improvements start to take effect as well. So today is really kickstarting an effort to improve that communication. But thank you to those who have been engaged to provide feedback so far. Thank you also to those who have over time engaged with us to report performance issues. Of course, it's not open source projects being what they are, it's not limited to performance problems, and there are so many other aspects to it. So not to ignore those situations where others have contributed, but particularly on the performance side of things, given this is the focus for today, thank you to those who have engaged, and especially to those who have submitted code as part of Unity. It's sort of becoming a bit of a broken record thing for us to say that when we have something in Unity that helps on two levels critically, from a correctness perspective, it helps us to evaluate things and work out whether a change we've made is the right change or not. But from a performance perspective, as well, and this is going to be increasingly the case as we go forward, we are absolutely going to be looking at projects in Unity to help steer and prioritize where we sort of spend our time on performance improvements and looking at where things are slow and why they are slow. So for the sake of being that broken record that I just referenced, if you would like to submit your project to Unity in any way, shape or form, please just let us know. It is a huge help to the Q project. But if you sort of turn it around the other way as well, if your project is in Unity, it will also help us to be much more focused on how we're addressing performance and correctness issues as well. Moving down to the third bullet point there, this is something we've sort of been sharing a bit more in Slack and attempting to do. Discussion 2846, the third bullet point there, addresses how we are trying to improve communication via the Q open source project. That's a sort of a higher level thing of how we're looking to use GitHub projects to help with our issue management, but also the communication from sort of like a roadmap perspective of how different parts of the project are being worked on, what's planned, what's in progress, what's in the backlog, and what is done. And as we'll show in a couple of slides' time, that trial is working pretty well so far. It's working very well on the module side of things. There's still a number of improvements that we would like to make to this, especially when it comes to sort of people self-serving and looking at these roadmaps and seeing where they are and feeling like they have all the answers they need. But from a project management perspective, it's working incredibly well from our side. And we just want to ensure that that's then giving people useful updates from a public perspective as well. We will still do calls like this, and we're very happy to do so. But what we want to, one of the bits of feedback that we've had is that having these calls is great, but I don't want to have to play through the entire video to see where you are with something, which is totally reasonable. And so what we're going to, there's two aspects of that. Is the project board will enable you to get a sort of a bit of a snapshot. And what we're also going to start to do, especially with the evaluator, is provide a bit more of a running commentary on where we are with things. Dare I say, it's sort of like a newsletter of sorts. The fourth bullet point there, the discussion of performance in Q2857 is really a follow-up to the Slack thread. And what we sought to do in that discussion is recognize in a more, in a less ephemeral way, in a public place, that actually things haven't gone right when it comes to communication on the performance side of things, and hopefully start to address some of the concerns that people have with the communication side of things and do a better job of sharing the progress we are making on it. And so again, that's how we find ourselves here today on this call. I just referenced the regular updates to the performance umbrella issue. That's 2850. Here, oh, sorry, I've put these slides in the wrong order. I beg your pardon. Literally 10, 15 minutes ago, Marcel just posted the first of these updates to that issue. This is a longer form update than we will plan to do going forward, but it being the first such update, it sort of necessarily includes sort of a bit more prose, a bit more explanation on how and where we find ourselves today. So the updates going forward will be shorter. If, however, you think they need more detail or less detail or whatever, they're not giving you the answers you need on things, please let us know. Again, it's a tricky thing to try and provide levels of detail that satisfy absolutely everybody, but so we're going to try and get the middle ground, as it were, but please, either way, just give us feedback on whether it's working or not. I referenced the the Evaluator roadmap project, which is linked from, it's not linked from this slide, I will fix that. The Evaluator roadmap project is now our attempt to actually provide this high-level bird's eye view of where we are and what's in progress. So I'm not going to focus on this right now because effectively we cover the detail of this on the slides that follow. But at a high level, this should be a way of anybody just turning up and looking at the Evaluator roadmap and saying, okay, what's going on right now, and getting the answers from these high-level issues here. The reason we haven't got, right now we're of the opinion that we don't want to include all bugs, for example, in such a project, is that starts to then create a level of noise where it's hard to see what sort of the big pieces that are in progress at any point in time. However, we do see it as a necessary thing. We don't want to lose track of the bugs either, or the feature requests, for example, when it comes to the Evaluator. So we are looking at perhaps, we're just starting simple for now, and given that these are the main points that we understand that we need to do better at communicating on, this is where we're starting. And then we're going to work out, well, how can we perhaps have a couple of different views that allow us to see feature requests and bug reports, excuse me, in this same kind of view here. Because of course, as we're fixing bugs, if they are in progress, we'll be marking them as in progress. Feature requests, if they're planned, for example, will be indicating that they are planned as well. So this project is absolutely not complete yet in terms of all issues. Is it the case that all issues that should be part of this project are in there? No. We're, as I said, as part of this attempt to improve our communication and better share the roadmap of where we are and what things are in progress, it's a work in progress. We're actively trying to add things on a daily basis and ensure that things are properly categorized so that you can self-serve on a lot of this information. Just to perhaps sort of put some minds at rest here, in that we're not just doing this for a communication purpose, is that we are actually, it's kind of serving two critical roles at the same time, is that we've worked out that we can actually use this very effectively from a project management perspective as well. So we're using this live as we go. And if you were to take the modules roadmap, for example, we review that on a daily basis, as we do with the release roadmap. And Marcel is now going to be using the Evaluator roadmap on a daily basis to sort of say, here's what is effectively being communicated as to what's in progress. Is this reflecting things? Where are there some updates required? And albeit we will start to post these updates on a periodic basis, we're aiming for fortnightly, excuse me. If there are any updates to issues that are within the roadmap that's can be updated slightly more ad hoc along the way, we'll absolutely do that as well. I think that provides a bit of background on where we are today and the context for the call today. Marcel, I think I'm going to hand over to you for a sort of a high-level recap on where are we.
Yes, thank you. Yeah, so why in the first place do we have a new evaluator at all? So if you, so a long time ago in the community, somebody sent me this video of incremental, and they said, like, look at the developers. It's a spreadsheet-like library. And they said they had to do 7 re-implementations, and maybe you can learn something from it to avoid some mistakes. So the only thing I learned there is that, like, yeah, we need to have a bunch of re-implementations as well. So it's very hard to see in advance certain pitfalls, and like from each implementation you learn. But basically, at this point, the alt evaluator grew way too complex. There were some really bad interplays between disjunctions and the closeness algorithm that were really incredibly hard to fix, or almost impossible to fix with this alt implementation. Also, there were more features added over time, which were all quite disjointed. So in order to fix something, you had to adjust many things in many places, and it was getting very hard. And as I said, some of these fundamental limitations in the algorithm. So the new evaluator so fixes this, which allows us to fix some of the bugs that are outstanding in a more straightforward manner, and also fix these fundamental optimization issues. So basically, we have, as we already mentioned, 3 major categories of current performance issues. There's a whole bunch more that will you know, like be able to accelerate Q much further beyond that. But these are the 3 main issues that people see with the alt evaluator, and you know, which cause the alt evaluator not to meet the performance that it should have given the algorithm it uses. So I'll discuss those a bit. So first of all is the closeness algorithm. So one of the problems here is that these are auxiliary structures that are built besides the vertices that are built up, so that people use. And the problem with the algorithm is that these auxiliary structures cannot be reclaimed. So they accumulate during the evaluation, and at the end they will still be around. Theoretically, you could clean them up after you're done evaluating and you return the value, but that's too late at that point. And the result, the reason for it is that you have backwards pointers in these graphs. So even if you're done processing, you would still have to keep the memory around. Not only that, these auxiliary structures also grew with the depth. So as soon as you get more and more deep graphs, they grew for each node. So it wasn't necessarily quadratic, but definitely superlinear. So the performance there was absolutely horrendous. And to make it even worse, the way the closeness algorithm was implemented prevented this us from being able to see whether 2 disjunctions would fail, which disallowed us from filtering disjunctions early. So that basically means we had to first blow up the search space in disjunctions before we could shrink it again. And this was not the only disjunction performance problem, but that was definitely one of them. So in the new evaluator, the auxiliary structures are still there, but they now point in the other direction, which means we can actually reclaim it. They're not fundamental, so they don't need to stay around anymore after a node is processed. So that's also allows us to get rid of it much more quickly. And then on top of that, the new evaluator is also much more compact in its evaluation. So it will try to finish nodes as soon as possible. And as soon as the node is finished, it can be reclaimed, versus the alt evaluator, which would be doing partial evaluations, sprawling throughout the tree without really any accounting of what was already being done. So this would basically mean that we can go from an almost n-squared additional memory requirement to a constant extra memory requirement, which is quite a big improvement. So then the other one is a repeated evaluation of incomplete expression. So if you have within a node like multiple expressions that all depend on each other, so for example, they might be chained or whatever. So one expression depends on the outcome of another. Especially if this was within a node, then basically Q was not very good at recognizing that. So basically what it would do, it would just iterate over the expressions, like when is the next one I can evaluate, when is the next one I can evaluate, until a fixed point was reached. So the idea was that in practice, this wouldn't occur very much, and this wouldn't be much of a problem. Turns out in practice, this actually does occur a lot. And this is especially bad when you have like comprehensions, and you have to keep reevaluating these comprehensions all the time. So the new evaluator basically has a low-level sort of micro scheduler. And what it does is, as soon as an expression is evaluated, it cannot know in advance really if there's a dependency. But as soon as it figures that out, it marks this in such a way that it doesn't get reevaluated until that dependency is satisfied. So it's basically does this dependency analysis, which is very easy to do, but you need to do it at the very least. And so this already works. It's already checked in. This is the scheduler sort of independent of the evaluator. It really is not, but for testability, it's its own thing. And we can see in the Q evaluations now that whereas so I have the old evaluator, the new evaluator side by side. So when I'm debugging, I can see it. And you can see that the number of redos is as expected, so significantly less. So basically, the fixed point computation was, when it comes to processing these expressions, n squared, and now it's linear, so 2n basically in the worst case. There's some possibility that this still occurs if you have very deeply nested comprehensions. So this is a more esoteric case that still could be exposed, but we can apply the same technique there. That's not done now, but we and I haven't seen problems with this in the evaluator, but if this is a problem, we can fix that too. So disjunctions. So this is really a biggie also. So there's actually 4 problems with disjunctions. One already I mentioned, which is really a function of the closeness algorithm being able to not allow us to filter disjunctions early. So this basically means I have to do a cross product of all the disjunctions before I even can see if something is failing. So that is fixed. There was additionally a bug that it was exponential actually instead of quadratic, which is really, really bad. So this was introduced in 0.3. So this is now addressed as well. And then also the new design, which is very hard in the old implementation, but in the new implementation, a lot simpler. So the control flow is much more amenable to being able to make use of discriminator information. So whether it's, so specifically if you have, for example, a kind field, which is unique for all the disjuncts, we can basically select the right disjunct now. This is not yet implemented, but at least it's prepared for it. We can select the right disjunct without ever having to expand the disjunctions in the first place. So this will be a huge win. And then another one, which is related to disjunctions also. So what we've seen with disjunctions is, what is one problem is if somebody has a very large definition of disjunctions and then people reference it, then a lot of these things get recomputed over and over and over again, even though that's not really necessary, especially if you create just a reference to a node and you repeat that somewhere else. So this basically we could do with structure sharing. I implemented this for the alt evaluator, but again, it was way too complicated to make this really work in the alt evaluator. And this is now much easier than new evaluator. So this will not be part of the sort of first iteration, but this is like a fast follow. Paul?
Yeah, just to re-emphasize the point that you made there, because folks who are on the call who have been with the project for some time, have seen things like structure sharing before, have seen a number of these points about memory issues before. And just to re-emphasize the point that Marcel made earlier on, the reason we're talking about these in the context of the new evaluator now is because of fundamental limitations in the old evaluator that, for various combinations of reasons, just made it impossible to implement them, or extremely hard to implement them in a sensible time frame with the old evaluator. So this is why we are effectively still talking about them, is that these things are enabled by the new evaluator, where before they were not possible with the old evaluator.
Yep. And there's a variant of structure sharing, which I'll just call fine-grained structure sharing. So this there is also a performance issue if you have many chainings of references. So types that build on another type, another type, on another type. So this is a common pattern in ToolsFlow. And there, basically, every time you reference, it's the value is recomputed. So this also is more or less a quadratic, in the length of the reference chain evaluation. Even though in practice it turns out it's a little bit sneaky, but in practice it's actually not necessary. So this was also implemented in the old evaluator, showed to have like huge improvement gains, but it was hard to finalize and then fix the last bug. So this caused some disruptions. Also, that didn't really work in the old evaluator, but for the things where it did work, we saw huge performance gains. So this is also something we can do in the new evaluator. Yep. So what's the status? So in the last community call, when I talked about performance optimization, I had a very similar graph. It's very similar numbers. The main difference is that at that point, we didn't include any of the tests that had any disjunction. So right now, the number of tests that is included here is about double of what it was before. So we're now basically back to the same, almost complete with disjunctions. So what was very comforting is that there were few, like a handful of errors that were discovered that were not disjunction related, but that were disabled because the file had disjunction. So by and large, though, there were very few of such errors, so that's comforting. So of these, now 16% of the normal errors left that you see there, of the P0 and P1 errors, or that 6%, about half of them are not disjunction related. So these are these other cases that I refer to. So 6% is still skipped because there is some crash, and I mostly know where that's coming from. So there's now lots of panics in the implementation. Some of them is for unimplemented. So some of the built-in stuff is not implemented, especially sort. So I need to do that. So that's actually a good chunk of those is sort related. It shouldn't be too hard to fix that. But yeah, there's a few of these tests that are skipped because they're too annoying to include them. So for all the other tests, there's basically I will, in the CLs, I check in the diffs with the to-do, what is remaining to be done here, with an explanation what needs to be done. But for these other 6%, that it's too cumbersome to do that. Yeah, so the aim is, as much as possible with this implementation, is to keep the semantics. That means in some cases even try to not fix bugs in the old evaluator before releasing it. But I'm not gonna go out of my way to reintroduce bugs, of course. But one interesting one, which is now fixed in a new evaluator, which is the not allowing definitions in closed definitions. So you're not allowed to reintroduce a definition or introduce a new definition in a closed definition. So that is something where we probably want to reintroduce that bug, because I can imagine that can be quite disruptive to not have that. Yeah, so next steps. So the first thing is, if we go back here, once we fix the P0, P1, and the skipped bugs for the most part, maybe if something is very esoteric, we'll we'll skip it. So P2 and P3 is mostly reorderings and some error positions that change and things like that. So not very big changes. But for the P0 and P1, we want to really have as much as possible before we enable the Q experiment. And then once that's done, that basically means you would have the a lot of the big O improvements, but not yet when it comes to memory use. So the old, so what's very tricky, because we have to do our own memory management, is that we so reclaim used memory and reuse it, so you don't have to do allocations. So the new evaluator just turns that off essentially, and in some cases not even return the memory. So it might actually use more memory initially, or for some cases. But the idea is that as soon as we enable the experiment, we're going to clean that up and reclaim the memory, and it should be able to reclaim much more memory than the old evaluator. Then the next step would be to bring at least the error messages on par with the old evaluator. So that is add back missing positions and stuff like that. Maybe even improve the error messages when we can, although that would be a separate project really to really improve the error message. Some error messages are already improved as a side effect, by the way. And then also after that is implementing the further optimization. So we have the structure sharing implementations mostly done. We know what needs to be done there. And also the disjunction discriminator filtering. There is a sort of intermediate, slightly more general implementation where you don't necessarily have to have a discriminator field, but that is a little bit more expensive, but will still trim things down a lot, that we could implement quite quickly. So we should see a big improvement there as well. Yeah, so
I can jump in here if you like on
sure, go
this
ahead.
piece here. This view really should echo the previous slide. So in terms of next steps, the things that are in progress that you see here are the things that Marcel is actively working on right now. The planned things are really those next steps that Marcel just referenced here. And so we are going to be using this view to give that high-level perspective on, okay, where are we with performance work, especially in the evaluator. But as I said, we'll also start capturing bugs within planned, in progress, etc. when we've sort of worked out how to get those perhaps 2 levels of granularity view on things. So how we're going to be communicating by sort of talking in future by talking through this project view here. The written updates, that the first of which Marcel just posted earlier on, will be shorter in form, and they will likely sort of reference specific items within this project roadmap here. And so hopefully our updates going forward will be better, they'll be clearer, they will be more succinct than we have sort of necessarily been more verbose today to sort of set the context for things. But please, as I said earlier on, where we can improve the level of granularity, whatever, let us know and we can adjust that as well. The one other thing, I mentioned it in the discussion we created following the Slack thread, is that for those who have engaged with us to share performance problems, especially adding things to Unity, we're in the process of making sure that our we're refreshing effectively our understanding of how your reproducer works with the new evaluator as it currently stands. What we'll be doing over the coming weeks as well is engaging to touch base and make sure that the configuration we have is a current reflection of the performance problems you're facing. So say for example, a situation where that would be different, for example, is where you say, oh, actually the snapshot that you have in Unity, for example, is a bit out of date. Actually, you should use this snapshot here. Perfect. Then we can refresh on things and we can then make that part of our analysis going forward. It is part of Unity and the checking of correctness and performance, as we said. Also, I think that was all I was going to say on that side of things, and leave it to Q&A if that's good for you.
Yep, go ahead. Any questions?
So firstly, thank you to those, again, who have asked questions and points that we've covered in Slack. If there's anything that you would like to go over again as part of that conversation, very happy to now that we're live on the call. Otherwise, if there is other questions, very happy to do that as well.
So just to emphasize, this is like my main project. So I'm working on this most of the time, essentially. So it's not that this is once in a while I work on this and make progress. This is now getting out an experimental version is highest priority at the moment.
I had a question. Can you hear me?
Yes, we can.
Yep.
Please go ahead. Yep.
So about the closeness algorithm, I was wondering, was it costly in time to? I mean, does the closeness algorithm really is heavy on the performance, or how do you check the closeness of? Could you keep
Yeah, so one of the issues with Q is that it has this arbitrary order of evaluation, right? But with closeness, you still need to know, okay, when do I have enough information to say, okay, this is close, right? So even though we could accumulate things incrementally, which was very handy and actually necessary in a lot of cases, we only had enough information for closeness at the very end, which made elimination possible. And then also what slipped in is that some of the position information for errors was conflated with the closeness algorithm. So we had all these pointers, like we needed to keep track of where does does something come from a definition or an embedding and whatever. And this auxiliary structure was used as sort of a history to keep track of that. And what we do right now is very different, is that in a conjunct that's registered in a vertex, instead of using this auxiliary structure, we only use the auxiliary structures to create a tree. So that instead of the conjuncts now being a flat list, it's actually a little tree that reflects the embeddings and the definitions. So what is closed, and we only use the auxiliary structure to create that tree and make sure that everything gets collated into that tree, and after that it can go, basically. So that means if you now have a node that you evaluate and there are a few dependent nodes, it sort of finalizes the inner circle, and then after that you can reclaim all the closeness information.
Okay. Nice. So basically, at the end of the evaluation, you check if the closeness is verified or not, and you can produce good errors.
Yeah. So before it was at the end. So the nice thing now is we know it as soon as we can, basically, because it's all done with sort of reference counting. So
with this auxiliary structure.
Yeah, so we can fill much more quickly, which is good.
Okay, great.
With this junction. And another side benefit of this is vertices right now have a list of conjuncts, which always has to be created. That means we have to create a go slice for every vertex. But the way conjunct groups work, we can actually start collapsing that and have a single conjunct and only need the list if there's actually a list. So there's but that's not done yet. I didn't notice it. That those are further memory improvements that go beyond also what even the simple vertex data structure now supports.
Yeah. So by conjunct groups, you mean when you parenthesize multiple conjuncts inside one conjunction?
Yeah, it's now a tree basically, but we can use that to also collapse the conjunct lists, because most vertices don't have more than one conjunct. So it's too expensive and unnecessary to have a list.
I should say actually that thank you for the question. If folks would like to understand more about how the new evaluator is implemented, we'd certainly be happy to talk about that more on sort of later office hours sessions, if it's sort of particular interest, particularly where sort of folks might be interested from like a more theoretical perspective, and or sort of helping out in some way. We'd be very happy to go into those sorts of details.
Sure.
Great.
So Jonathan,
sorry, go ahead. I was just about to move on to that one as well.
Yeah, so Jonathan mentioned about releases. So the evaluator changed because it is an experimental thing. It's not really tied to like a major release at the moment, I would say. So as soon as the experimental version can be in, it will be with the very next cut, right? It could be 8.1 or an alpha, hopefully not too far away anymore.
So I think this is actually a very good question, because it reflects on something we did wrong before. What we did was we said that 0.7 was going to be the performance improvements, and that had two problems, in that it meant that our communication was then tied to saying, basically implying that all performance improvements would be in 0.7. It kind of also meant that we couldn't do any releases that we might wanted to have done for prior to 0.7, because we ran out of numbers at that point. We'd already done 0.6. We couldn't, as we were starting to need to release some of the modules work, that was then impossible. So I think that was a big mistake, because then when we released 0.7 and there was no mention in 0.7 of the performance changes, quite rightly everybody said, hang on a second, but you said this was going to be the performance release. And that was sort of like double bad, because we had, whilst we did communicate it at the time, we certainly weren't at the level of communication that we're trying to get to right now, in terms of being clear on where are we with things.
Yeah.
It also meant that we had no opportunity to say, well, actually, we will do these things incrementally, as it then proved to be the case. Complications such that we were like with disjunctions, meaning actually we need to do this incrementally, and actually it's safer from a risk perspective as well. So, Jonathan, I don't want to avoid the question though, because effectively there's a question hidden within your question there of when is this stuff going to land? That is something that we are looking to get more precise on. We've in the written update that Marcel has provided, you can see there's a list of the active changes in Gerrit that Marcel is working on. The one that's the top of that stack, which is the first cut implementation of the new evaluator, has already been reviewed. There are some changes that are being made to that, and there's a tracking issue in GitHub for folks who want to subscribe to the GitHub issue for sort of updates on when these things land or not. It's what we plan to do, and although we're not there yet, is actually start to, on our release roadmap, start to drag these issues into releases that we are going to target. For folks who are following the release roadmap, that's what we are already doing with the modules side of things. So we're heavily using it for modules. Modules is significantly easier in that respect, and there are much finer grained bugs or features that we can very precisely say this will land in this release. There are actually some larger parts of modules where we can't, and sort of directionally, for example, we're saying, well, we're not quite sure exactly when this will be in, but it has to be in before we release version 0.8.0. What we're going to do over the coming weeks is get more precise on things from the evaluator perspective as well. So really hold ourselves to, okay, fine, this is what we're going to aim for here. This is when we're going to try to have, this is where we're going to, for example, allow you to enable the new evaluator via Q experiment, for example.
So I'd like to answer Kevin's question. So one thing that I didn't mention, which we'll do very soon, or even before the turning on the experiment, is to align the counters a bit. So there are counters right now in the new evaluator, but to make sure that they're somewhat comparable to the old evaluator. And that means that even if there's like memory issues, so the thing runs slower, you can at least see if from a time complexity perspective it's performing better, right? Like the counter should be going down essentially, and the counters can really help identifying an issue and reducing it. So that's one thing. So another thing we had in mind to do eventually is to have a Q profiler. So one thing that we could do, for example, is to see which path in the tree has the most operations, right? So that would be a fairly, I mean, maybe expensive thing to do, right? Because you need to keep a map, but still doable, right? It's still a doable thing to do to keep track, or maybe we could keep it in vertices or something like that. But basically have a way of tracking the hotspots within a configuration, right? And then we can spit out these numbers, like where is the most work being done, and then we can use that for make debugging a lot easier.
It's a great question, Kevin. I actually feel bad that we should have probably included a slide dedicated to this, Marcel, because
for the stats, yes.
For the stats, yeah, because fundamentally it's a very natural thing to reach for pprof with Go, but the nature of the algorithm in Q makes it almost impossible to look at such a profile and understand where the issue is. Yeah. And so hence the Marcel's reference to like a Q performance analyzer there. It sounds very grand. It would start very basic and would grow. But the thing is that what that would allow us to do is it would allow us individuals to say, well, I've got this complicated configuration that is taking a long time to evaluate here. Let me run the stats on it and send the stats, which are totally anonymized at that point, to the Q team for them to have a look. You can sort of see this is like something close to, oh my goodness, the word has totally gone from my head, and I'm going to look at Daniel here to help me here.
Like bprof?
No, what you can opt into in the Go project now.
Telemetry?
Telemetry, thank you. The word just totally escaped me. The idea being that if we can gather these sorts of stats, you'll be able to see yourself in sort of real telepathy indeed. You'll be able to see in Q terms why this thing is expensive, with what Q operations are making this expensive. And then if actually we say, hang on, we really want to target and fix this from a cost perspective here, that's the point at which we can say, well, seeing these stats, we're going to need to look at the configuration itself and understand more deeply how and why it's behaving as it is. But the reality is that it's near impossible to look at a Go pprof output and say, oh, and the answer is X.
So actually in the new evaluator, that might actually become also a little bit easier. It doesn't help you debug your configuration per se, of course, but in the old evaluator, everything was on like the most computation was on a single path that was recursive. So that means so unify was by far the most computation. Well, great, right? Like, so now there is, for example, if disjunctions are processed, it's deliberately on a different path, so it will be at least a little bit easier to measure from a profiling perspective, like where the time goes. But seeing the hotspots in configurations, I think, is a great thing, which I never realized I can probably add the counters in Vertex. That would be quite easy to do it. That way it would also work with the old evaluator. Might be interesting.
Having just, I didn't mean to sound like I was beating up on pprof there, because of course, as I understand it, and I would definitely look to Daniel on this point here, effectively the technology, for want of a better phrase, behind pprof is not specific to CPU or memory profiling at all. So conceivably, it is something that could be used for actual capturing of the Q statistics as well, which would then mean that tooling that allows you to visualize whether pprof is the format or not, or whether that's the bit that is specific to memory and CPU, I don't know. Yeah, exactly. So I think it might well be that we can reuse some of that so that we don't have to implement our own visualization of this sort of thing. But again, getting some counters in place and some stats is a starting point for that, and then we can sort of aggressively work on refining that and improving it. Oh, okay, great. There we go. Thank you.
Yeah, so it seems like it takes a protobuf that contains a bunch of position and call stack information with some sampled statistical data. So it seems fairly generic, you're right.
Yep. Anybody else with any other questions that we can cover today? Please, Jonathan.
Hi, I'm sorry, I joined the call late, and I think that you guys were talking about this in the slides when I joined, but I have a reasonably large Q configuration base, by large, like tens of thousands of objects like in our configuration. And one of the problems that we have is that our configuration data is partially normalized because if we just use references and try to evaluate everything, as sort of like a materialized view, it's very slow, and the resulting data is kind of too large anyway. But so our data is somewhat normalized, and so the an analogy that I can give is like if you had a pantry with inventory of ingredients, and then you had recipes that have references to those ingredients. We want to make sure that any ingredient mentioned in a recipe is actually in the list of ingredients that we have in inventory, right? And so initially, we did what looked like the easy thing and specified that, like an ingredient name is a disjunction using like or over a comprehension that just looks at the keys in all of our ingredients in inventory. But the performance was really unacceptable doing that. And so we kind of worked around that by writing a lot of manual checks, where we basically go through each integrity check that we want to make, and we use an object comprehension, to build an object of the keys and check whether basically whether we can unify unify the foreign key, for is how I'll simplify it.
Yeah. So
I'm sorry.
So
So like that would be like a huge quality of life improvement for us. I understand that there are good reasons why it's slow now, but it's a pretty big pain point for us. And I'm basically the only person in my company that can write these integrity checks manually because the learning curve is kind of steep.
Yeah, so that sounds like this is this discriminator field thing that I mentioned, right? So aside from disjunctions where there's a bug now where it would go from exponential to quadratic probably very quickly, and also the failures would be found very quickly. If these disjunctions of all these different types, right, have a unique key or have something so that you cannot unify with themselves within the disjunction, right? Something that distinguishes it. Then it really should be dramatically faster. Maybe not in the first iteration, but we have this algorithm written such that we can do that, right? Like that we can have this this pre-filter. So that means that the disjunctions wouldn't even be computed. It will pick immediately the right disjunction, insert it, basically implementing what you described with comprehensions, right? But then natively in Q.
Wait, are you saying that that's available today, or that's what you're working on?
That's the new evaluator that I'm working on. Yeah, so it's structured so that that I can do that basically. So the first iteration, so when the experimental version will be released, will not have this. It will still be probably a lot faster, but it will not have that should But the idea is that that we add these filters after that pretty quickly, so that which should really speed up disjunctions.
What I'm just doing what I'm doing, Jonathan, in response to your question of is that something that is available now or you're working on, I'm adding an issue to the project board that will capture specifically that point around when that is available, that piece. So when, for example, you should be able to use disjunctions with discriminator fields and see that performance improvement. So for you personally, and perhaps others, because I know you're not alone in wanting that feature of disjunctions basically being massively optimized according to the fact that the elements in the disjunction are mutually exclusive, it makes sense to track that improve our communication is where people have questions like this. This is a perfect example to my mind of something where we don't have something in the project board. There are a sufficient number of people interested in it. Let's get an issue in there, and then you'll be able to see it's planned but not yet in progress, and then you'll also be able to see when it's closed, when it's implemented. Great. Now I can look forward to it being available in a particular release as well.
Cool, thank you. The one other thing that I wanted to mention, at least specific to my scenario of using these for integrity checks, is that we actually get much better error messages with these manual checks, because the way that I actually use like string interpolation as I'm building these objects that basically if they unify, then they pass, and if they don't, then they fail. Well, the consequence of that is that the string that I have formulated as the key, the comprehension, will get dumped to output as the error. And so it can say something like, like ingredient paprika not found in pantry or whatever, right? Whereas when we were using the disjunctions, I think that if I recall correctly, it would print every value in the disjunction. And it's like, well, I don't actually care about all of those. I care about the one that was not found.
Yeah. So if you can report that somehow, or how you would like to see certain errors in certain situations, that is very helpful, because it's hard to generalize it. I've been thinking about is how to do this with discriminator fields more properly. So we can probably build some intelligence around it, but it's still good to have user inputs there. I mean, we have the new evaluator is much more structured. There is much more information potentially that we can use also in constructing error messages. So at some point in the near future, we'll need to start thinking about that. So any input already collecting data around that is great. Daniel?
I'll mention very briefly that a couple of times on Slack, somebody's come with a configuration that uses a lot of conditionals. And I tell them, oh, this gets a lot simpler if you use disjunction, and then tell me, nope, we're not using disjunction on purpose because the errors are worse. And the reason is because when they get an error that they are interested in, that they want to see the output of, they basically get a dump of why all the disjunction branches were discarded, which is technically correct, but it's way too much information.
Yeah, I mean, one thing you can we could do is if we see that all the disjuncts and the disjunctions are mutually exclusive, which we should always do, not which we should always do, what generally is advisable, then we can probably see, okay, what are the fields that they all fail on, and then we then we can see if the user specifies a field that doesn't exist there, then then that would be your error message, right? That would be a much clearer error message. And the things in Kubernetes, this is very commonplace, right? So this is an extremely common pattern. So it's worth optimizing for that case, I would say.
We're coming up to time. Thank you very much, everybody, for joining. If anybody does have any follow-up questions that they'd like to ask for the discussion, please do. Thanks to everyone for joining and for the feedback. I think we'll likely hold another office hours in a couple of weeks' time. Probably that sort of makes sense, given we're sort of early in this process of trying to improve communications. There might sort of be further backwards and forwards. Let's just have a session where folks can join and ask any questions they might have. In the meantime, we'll post the recording from today's session and look forward to seeing folks on Slack and in other venues as well. Thanks, everybody.
Thank you very much.
Thank you.
Bye-bye.
Cheers, bye.